Okay, so recall that in your previous courses or previous units even, you learned to solve exponential equations by rewriting the expressions on both sides of the equation with the same base. Okay, so what that means is you write the left side and the right side using the exact same base, and the powers or the exponents will help you actually solve for the variable. Okay, so if you had an example like 2 to the exponent x equals 16, what you would do to try to solve this is try to rewrite 16 with a base of 2 so that you can equate the exponents and solve for the variable. So I would rewrite this as 2 to the exponent x equals 2 to the exponent 4. And then since the bases are the same, I can say that x is equal to 4, which is the exponent part. Okay. We can also use logarithms to help us solve exponential equations. So for example, if you have some base to an exponent equal to another base to an exponent, you can take the logarithm of both sides. So we're taking the common logarithm of both sides. And then use the power law to bring down the exponents on the x on the right side and on the left side. And then at this step, you can divide both sides by the logarithm part so that you can equate the exponents. So that's another way of looking at the same kind of a problem. Now, the other part that we're going to be looking at is solving exponential equations, and we're going to go through writing the powers with a different base, and we're going to use that to help us solve exponential equations. Okay, so if you're solving exponential equations, remember that exponential functions and equations and expressions even can be represented in many different ways by changing the base. So for example, I can rewrite 16 with a base of 4, or I can even write 16 with a base of 2. So a couple different ways of writing the same value but with a different base. Oftentimes it is useful to express the exponential expression using a different base than the one that's given. So for example, if I have 2 to the exponent x equals 64, ideally what I'd want to do is write this as a power with a base of 2 in order to actually be able to compare the exponents. Okay? So here are some steps to actually solving an exponential equation. So to solve an exponential equation, you want to change the base of one or more exponential expressions. And then once the bases of the expressions on the left side and on the right side are the same, you can set the exponents equal to each other and then solve it for the variable using techniques you know from before. So if I look at the example where we have 2 to the exponent x equals 64, the first thing I'd want to do is change the base of the right-hand side. I can't change the base of the left-hand side because it already has the exponent applied to it, and that's the exponent that I'm trying to solve for. So ideally I'd want to change the 64 to a base of 2. And so I get 2 to the exponent x equals 2 to the exponent 6. And once the bases are the same, I can equate the exponents, and so I get x equals 6. Okay, in this case I didn't have to do too much rearranging, but you will see some examples where you might need to rearrange the exponent parts once they're isolated, and then try to solve for the variable.